hope you're watching this after solving the problem. This is rather a simple question, but over years I noticed a misunderstanding among students. Uh, let's review the definition of passive and active elements. Using the sign convention, which I shown here, uh, a passive element by definition is an element whose IV curve is either in region 1 or 3, if you call these four regions, region 1, 2, 3, and 4 consequently. So, for example, by definition, a positive linear resistance is a passive element because it's always in region 1 or 3. By the same definition, a PN junction diode is a passive element. But if you shine this PN junction with light, it will become a solar cell. So the IV curve is something like this. And it's not a passive element anymore. We call it active. But note that it does not mean that I times V of an active device is always positive. For example, in this region, or in this region of the IV curve, it consumes power. It does not generate power. Same for voltage and current sources, which are the IV curve looks like this for a current source. In this region, I times V is positive, it consumes power, and in this region, it generates power. For voltage source, also the same. Note that what I said is using this sign convention for both active and passive element. Usually for current and voltage sources, we don't use this convention, but with this convention, what I said is true. With these two comments, hence the solution easily will be that yes, here the voltage could be negative. Simply, if you connect it to a voltage source with such polarity, V is easily negative. For example, assume that the voltage source here is 2 volts, then voltage here is -2. In this configuration, this voltage source generates power and current source consumes power. And for the second part, easily one solution could be a short circuit like this, and neither element generates or consumes power. Hope you enjoyed it. Ciao.